This video is homework chapter 8:1. So this is going to be the intro of what we're going to do next, which is called confidence intervals. It is the last main theme of statistics. So the first thing we need to do is review the difference between a parameter and a statistic. So I want you to read this question, underline the key information, and identify which one is the sample, which one is the population, and what are the statistics and what are the parameters. So do this. So I'm hoping that you said that the sample was 1473 randomly selected people and the population was US adults. So we select the sample from the population, and hopefully it's a random sample, which it says here. Now, out of those in the sample, 124 of them said that they were vegans or vegetarian. So notice we see the word of. So this actually indicates that it's a proportion. So if it's a proportion, we're going to do a fraction, and specifically we're going to do 124 divided by 1473. Because this came from the sample, this is called a statistic, and this is actually the sample proportion. So we call this p hat. Okay, now what we want to do is we actually want to use our sample statistic, p hat, to estimate the true population number, which is called p. So ideally, this is the concept of inference. We take a sample, a random sample from the population, and the goal is we want to use that sample statistic to estimate the p, which is the true population proportion of all vegans. Okay, so this is the goal, that we want the statistic to estimate the parameter. Now, another name for a statistic is called an estimator, specifically a point estimate. So in the box down below, in this green box, it says point estimator or point estimate. That's basically another name for statistic. So it is a statistic, which is a number that comes from the sample, and it's used to estimate the true population parameter. So you guys know in this class, I've been telling you, it's too hard sometimes to get the true population number. I'm not going to poll all the people in the US and ask them how many of you are vegans. That's too much work. It's tiring. It's time consuming. So I'm going to use a sample and try to estimate using that sample statistic and hoping that it's a good statistic to estimate the true parameter. Okay, so in this class, the statistics that we use are, if we're talking about proportions, the statistic is p hat, and it's used to estimate p, the true proportion. If we're talking about means, the symbol is x bar, the sample mean, and we use it to estimate mu, the true parameter, true population mean mu. And if we're using standard deviation, the symbol is S for the sample statistic, and we use it to estimate sigma, which is the population number. So if it comes from the population, it's a parameter. Remember, PP, population parameter, and sample statistic, SS. So it's really important that you guys know your symbols, p hat and p, x bar and mu, S and sigma, and know that if you see the p hat or the x bar, that it came from the sample and not from the population. So now down below, we have the idea of the confidence interval. So this is one of the main things we're going to be doing from now on. It's a method of inference. So basically what we're going to do is we're going to take our sample statistic, which is in this column here on the left, let's say p hat or x bar, and what we're going to do is create an interval around it. And the interval around it is going to hopefully capture the true value of the true parameter. Okay, so this is called a confidence interval. And basically what it is you take your sample statistic and you create an interval that gives a range of possible values that will hopefully capture that true parameter value. So the goal is to hopefully capture the true parameter value. And we do this based on the sample statistic. Okay, so I'm going to read this again now that I wrote it all out. A confidence interval is an interval that we create around the sample statistic, and this gives us a range of possible values that will hopefully capture that true parameter value. And we base it off of our sample statistic. So if you look down below, this is a picture, and the picture is showing you in the middle we have a point estimate. So remember, another name for a point estimate is a statistic. So let's say we took our sample p-hat, as we talked about above. We asked the sample how many of you are vegans, and we found the sample p-hat. And what we do is we create a range of values around this, and this range of values is created by what we call a margin of error. So we take our point estimate, which I will highlight here in black, p-hat for example, and then I create a margin of error to the right and to the left around this sample statistic, and then that will be my interval. So the interval of values will be a certain number from a certain number to a certain number. And then the goal is to capture the true parameter value. So in the case of above, the parameter value was P. So the goal would be to capture the true proportion of all US adults who are vegans. So my p-hat hopefully is a good estimate of what p is, and I'm hoping that this interval that I create will capture the true p. You guys have actually heard of confidence intervals in life, because if you ever watch an election or an election season for a presidency or some kind of big election, they always talk about exit polls, and they talk about how they poll a sample of people, they get the sample statistic of how many people said they voted for a certain candidate, and then they make a projection of plus or minus a certain number of percentage points around that sample statistic to try to project the percent of people who are really going to vote in the whole election for that candidate. So this margin of error is basically the maximum distance that the true parameter can lie away from that sample statistic or estimator on either side. So we calculate the margin of error, and then we add and subtract that number, which we denote it with ME for margin of error, on either side of the statistic. And then to create the interval, what we do is we take our statistic and we do plus or minus the margin of error. So we take our statistic and we put it in the middle, and we do plus the margin of error on the right and minus the margin of error on the left. And then we create an interval, and the goal is to try to capture the true parameter within that margin of error. So the last thing we're going to do right now is do this example. So it says 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? Based on this poll, a 95% confidence interval was created for the population proportion for those who favor candidate A. So we were trying to spotlight the population proportion P for those who vote for candidate A, the true proportion who vote for candidate A in the population, okay? So what we're going to do is we're going to use a sample p-hat to estimate P. We're going to use a sample p-hat to estimate P. So it says we have an interval here. Here it is. And it says, what is the point estimate that was used to create this interval? So remember, I said the p-hat, or the statistic, is going to go in the middle of the interval, and the interval is going to be the endpoints on either side. So if I want to get this estimate, which is the midpoint of the interval, I just have to find the average of the two endpoints. So to do that, I would just do 0.48 plus 0.54 divide by 2 to get the average, which is going to be the midpoint. And that's actually a formula you guys did in geometry. So if I do this and I divide by 2, I get 0.51. So that means that the p hat that they used to create the interval was 0.51. So that 0.51 would be smack in the middle of this interval. So that means that when they took the sample of the voters from the poll, the sample statistic, the sample proportion of those who vote for candidate A was 51%. Now, what is the margin of error? So the margin of error is going to be this distance on either side of the sample statistic. So to get this margin of error, all we have to do is subtract the endpoint minus the middle, or the middle minus the endpoint. So to get the margin of error, I could either do this 0.54 minus the middle, 0.51, or I could do the other way. So let's do 0.54 minus 0.51, and we're going to get 0.03. That's going to be the margin of error. I could do it on the other side as well. I could have done this 0.51 minus 0.48, and I'm also going to get 0.03. So that means that there's a 3% margin of error, which means that the interval would have been 51% for the p hat plus or minus 3%. So 51 plus 3 and 51 minus 3. 51 plus 3 is 54%, and 51 minus 3 is 48%. And that's where they got that interval from. And the goal is for them to capture the true parameter P. So they're hoping that the true proportion of people who are going to vote for this candidate is between 48% and 54%. So how do we interpret this in context now? So the last thing to note today is we need to memorize this sentence, okay? I start and I'm going to highlight it here. It says, we are blank percent confident that the interval from blank to blank captures the true blank, okay? So we're going to insert in the blanks the key information. So I'm going to say we are, how confident? Well, it said it was a 95% confidence interval, and I'll explain more about what that means tomorrow. We are 95% confident the interval from 48% to 54% captures the true, and now we're going to put the parameter in context. So the parameter in context was proportion of those in the U.S. who will vote for candidate A. Okay, so ideally we want to be really confident enough that we can take our p hat and use it to estimate the true proportion. And the confidence level, that's the standard that we do use, is called the 95% interval, which some of you guys learned in Algebra 2 trig. So the confidence level is the 95% level, and then we put the endpoints here, and then we put the parameter in context here. Okay?